you can go ahead. I think the top piece was
15 over, I'd work that out.
15 over 4, right?
Yes,
And you were attempting to work out this part, so go ahead.
yes. And then you'll have bottom part, that is 2 times 3, 6 and 1, 7.
Mm-hmm.
That would be 7 over 3.
Mm-hmm.
And the takeaway sign, yes. And then the 5 over 6.
Mm-hmm.
And then you'd have to find the LCM,
Sure.
which would be 6. So you would say 3 into 6 goes 2 times.
Mm-hmm.
And then the 2 multiplied by the 7 will give you 14.
Mm-hmm.
Then the sign. And then a 6 into 6, 1, and then 5 ones. Right.
Mm-hmm.
Equal to 5 from 14, leave 9, so you'd have 9 over 6.
Mm-hmm.
And then you go down to that word. I don't want to call it. Don't think I pronounce it properly. But then you'd have 15 over 4
Mm-hmm. Okay.
on your left side.
Hold on, give me a second.
Okay.
Mm-hmm.
Divide.
Hold on there. Karan, you had 9 over 6, right?
Yes, I did.
For the bottom piece. But do you
Yes.
realize, does anybody realize that you could have actually reduced this?
Yeah, reduce.
Yeah.
Yes, sir. 3
Yeah,
over 2.
Right. So I think the best thing to do
Mhm.
is actually to reduce it. No, if you don't reduce it, it's not going to be wrong. You end up with the same answer, but it makes life easy.
Okay.
You understand?
Yeah.
Because while you have the 9 over 6 over here, it's still going to be reduced and get the same answer. But if you reduce it, if we get into the habit of always reducing your fractions, it makes life a bit simpler. So you're going to have divided by what? 3?
3 over 2.
2, right.
Sorry.
Yes.
Because what I have is totally different, right? I just want to know where the 3 over 2 came from, so to ensure that I'm following correctly.
Alright, so do you have 9 over 6?
No, I actually have.
Make a difference in a circle when you reach there, so to work out the final answer. It's going to be 3 over 2.
Right, but it doesn't make a difference. Hold on, Reggie. It doesn't make a difference, but I'm trying for persons to get in the habit of always reducing their fraction. If you see something, if you get a fraction, always reduce it. All right, but I think Reggie, your case is a bit different because you're saying you don't have 9 over 6.
Yes, because is it the 1 over the 2 and 1 over 3, right?
Mm-hmm.
So after I work out the top fraction, right, which is 15 over 4, then we move down to the bottom fraction, try to convert that, right? So I have 7 over 3 instead of 3 over 2. Minus 5 over 6. Minus 5 over 6.
Yeah, man, but that's what we had, All right.
Hold on.
Yeah, because the 9 over 6.
Somebody needs to turn off.
All right, somebody mics need to be muted. All right, go ahead for me.
Yeah, but sir, when you're canceling out, sir, I mean, I think that would have still be the 3 over 2, you know. I think it would be like 3 over 3. Wouldn't it be?
Alright, tell me when you get 3 over 3.
Alright. Alright, so for the let's say you didn't have the 3 over 2 there, right? And you have the 9 over 6. And then you reciprocate and it's now 6 over 9, right?
Hold on. No, the question is, when you reduce 9 over 6, you're saying that this is incorrect? Is that what you're saying?
No, I'm not saying that is not incorrect, you know.
Okay.
I'm
I
saying
think,
that
Go ahead.
yes, I'm saying that let's say for instance that because you're saying that it's going to be the same answer, right?
I see your answer.
Yes, but let's say you didn't reduce it to that 3 over 2 and you left 9 over 6, right?
You still get over the same answer, you know. Let me tell you, if you work with the 9 over 6,
When you get 9 over 6 from, I don't think you find out.
if you use the 9 over 6, you still end up with the same answer, because guess what? If when you get the final answer and you reduce it.
Yes, but when you cancel, you know, you're not going to get 3 over 2, you know, you're going to get 3 over 3.
No, but this is not the final answer. This is not the final answer. This is just reducing. This is just reducing.
Mr. Albert.
This is just reducing the 9 over 6 to 3 over 2. All right. No. Hold on. I think Rajay had something completely different.
Thank you.
Yes. He has nothing. Few things totally different. So let me go back to Rajay and hear what he's saying.
Thank you, Mr. Albert. All right. So I just want to know, just to be clear, right? The sequence is to work out the top, right? First, then we work out the bottom separately, right?
All right. Hold on here. When it's a work at the bottom, we're talking. What you talking about?
So after we work out the top and convert that into an improper fraction, right? Are we going to go ahead and convert the mixed fraction, then minus that from the 5 and 6?
Right.
Then the answer
You're gonna work out all of this
separately.
Yeah, man.
Then that answer will be
9 over
divided
6.
by the top answer, right?
Well, the
9
top
over
one.
6.
No, well, the top ones are divided by 9 over 6. Tell me
Why?
something.
Where does the 9 over 6 comes from?
Sorry, can I say something too?
Go ahead.
Because what she have, I have something totally different. She have 6 where she says 7 over 4 minus 5 over 6, right? So you go find the lowest number.
That's 7 over 3.
7 over 3, right?
Fine.
So the lowest number that can go into 3 and 6, you don't leave a remainder, right? So I have 12.
No, that's not right.
I have 12.
No, that's wrong.
So my workout is totally different from what she's doing right now.
But what she did was correct, because the LCM of what's it? All right, you have 3. We have 3 and we have 6. The LCM of 3 and 6 is not 12. It's 6.
The lowest common multiple.
That's
6 and 6 one time,
right?
And then 3 and 6 twice.
Right.
So that's the problem.
Yeah. Do you answer, miss? So you did something
One more
wrong
thing.
there. Hold on, Rajay.
I'm trying to figure out what you're saying.
All right. Okay, hold on. Let me. Boy, there's so many issues here. All right.
Sorry, can I try explain it to see if they would understand?
What to explain? Because there are so many issues. The LCM? No, it's something. No,
maybe it's how they start.
Pertaining to the.
Hold on, guys. Let me try to explain the LCM. All right. All right. How do we find the LCM? What does LCM mean? Roger, don't forget it, because let me tell you. Let me tell you. Lowest common multiple, right? The lowest common multiple All right. So, Chris, don't write on the thing, please. Okay. The common multiples of 3 are 3, 6, 9, 12, 15, etc. Those are the common multiples of what? 3. All right? And these are the common multiples of 6. Common multiples mean you keep on adding the numbers. So you have 6, you have 12, you have 18, we have 24, etc., etc. All right? All right, so when the question says lowest common multiple, if you look at these numbers, you realize that 12 is common, not true? 12 is common because 3 can go to 12 and 6 can go to 12.
Yes.
Right, but it's not the lowest. Which other number you see is common?
6.
6. Right. So this is not the lowest. 6 is actually the lowest because 3 can go into 6 and 6 can go into 6. All right?
Okay.
Do you get that?
Yes, I get it now.
All right. Okay. Tell you what, just to going back and forth, let me just work out number 4 again. All right. Karen, thank you very much. Here, I think we're almost
1 minute, sir.
We're almost finished the question and then this came. Yes, Raji.
All right. So before you work it out, I want to know, right? If I should times the denominators with their one another, like 3 times 6 to get the LCM.
You can't do that.
Am I incorrect?
Yeah. But let me tell you, it works sometimes, but it doesn't work all the time. Because in this case, if you multiply 3 times 6, what do I get?
18.
18.
Come
But that's wrong. That's not
18 is a higher.
Right. But
You want the lowest. Come on.
sometimes it works out, you know. Sometimes it works out. For example, 6 and 5. What's the LCM of 6 and 5?
30.
It be 30. And what you do? You multiply them, Joe. And that's what some students do, and they think that they do it all the while, you know. Look at this. 2 and 10. What's the LCM there?
10.
It's 10. If you multiply, you get 20, not true? The LCM is 10 because 10 can go into 10 and 2 can go into 10. Alright? Okay. Alright, so I'm gonna convert this mix to an improper. So that's gonna be 15 over 4. And then this now, you're gonna work out this separately, right? So this is a mixed fraction. So 2, 3, 6. And plus 1, 7, so it's 7 over 3. Then we have 5 over 6. Alright? And the LCM here is actually 6. Alright? So 3 into 6 goes 2. 2, 7 is 14. 6 and 6 goes 1. 1 times 5 is 5. So we get 9 over 6. Then now we reduce this. Now listen carefully. What I do to reduce this, you see? I look for what I call the highest common factor. The highest common factor is the highest number that is common between 6 and 9 that both of them can go into without leaving a remainder. That turns out to be what? 3. Alright? So 3 can go to 6 and 3 can go to 9. Can someone tell me the other factor, but not necessarily the highest factor, common factor of 6 and 9?
18.
As a factor, you know. Factor is something you divide into.
Yeah.
Apart from 3, what common factor can go into 6 and 9?
1.
It will be 1. Right, it will be 1. So the common factors of 6 and 9 would have been 1 and 3. But the highest common factor is what? 3. So when you're canceling, what you look for? The highest common factor. Alright? So 3 into 6 goes what? 2. 3 into 9 goes 3. So I encourage my students to always reduce your fraction. When you get a fraction away though, you always reduce it. It makes life easy. All right? Yes. Okay, hold on. Karen raised her hand. Yes, Karen, go ahead.
You're absolutely correct, because for this one that I did, my mistake was not reducing it. So instead, the end part of it, when you look at the work that I submitted, you would see that I would get this one wrong. Everything would be correct up to the point where I bring it down to the 9/6. But because I didn't reduce it, and then when I did the multiplication and the division down on the bottom, I did something wrong, and the bottom part is just totally wrong. But I just work it out and I got the right answer, but what I submit before is wrong.
It's wrong. Okay, cool. All right, so.
And also, Mr. Albert, you know, what I said before about multiplying and getting the 18, which was not the lowest common factor. However, I did it that way and I still got the same answer you got.
Yeah, but it doesn't mean that, you will get the full marks. All right, it's one thing to understand about CXE. You can do a question. Let me tell you, you can do a question, get the same answer, but your method is incorrect. What examiners are looking for, they're looking for reduction. They're looking for to see if you're reducing your thing in its simplest form. All right? Yes, go ahead.
Yeah, but that's what I was explaining earlier. I was using the LCM, but you're saying highest common factor. Because I use the LCM, I got 3/3. So now that you're using the highest common factor, it's 3/2.
Hold on, say it again. You're breaking up.
No, I'm saying that for the LCM, wouldn't it be 3/3?
Hold on. The LCM for what? 3 and 6?
I think. Alright, never mind. I think I mixed it.
All right, guys. You know what I think the problem is. I think the problem is that we might not remember the terms that I'm using. We have LCM and we have HCF. All right. So we probably need some brushing up on what they mean and how you find it. All right. A multiple. Let me just say it again. A multiple is going to keep on adding numbers. So the multiples of 5 are what? 5, 10, 15, 20, 25, 30. Those are multiples of 5. All right? If I ask you, what are all the factors of 5? Factors of 5 will be all the numbers that can go into 5 without leaving a remainder. Right? All right? Now, here what I want to know is, so when you cancel, I'm sure so. Suppose I have this. 100 over 75. How would you reduce that? Number one, what you do, you look for the highest common factor. All right? Okay. Can somebody tell me what you think the factors of 75 are?
25.
25.
Right?
10.
25. No, it wouldn't be. I wouldn't.
It wouldn't be 10.
It wouldn't be 10.
I would say 15. Yeah, right.
15?
Yeah, 15.
Yeah, 15 is correct.
And 5.
And 5, yes.
One.
5 and 1. So all these are factors of what? 75. All right? Okay, what are the factors of 100 now?
2.
Okay, we have 1, we have what?
10. 10.
5,
25.
10,
10.
What else?
25.
We have 20, not true?
You have 20, man. Yeah.
Yeah, 20, 25,
25, 50.
50, and 100.
100.
Oh, the number itself, not true? Oh, okay, I forgot that one down here, so. This one is also what? 75, not true? Alright?
Yeah.
Alright, so here we go now. If I want to cancel this, what do I look for?
The
Highest common
The
factor.
highest common. That's the word now. Common.
HCM.
25.
Right. So the highest common factor there is what?
25.
25.
25.
Right. So that's what we're going to use to cancel this thing here. All right. So let's use 25. Now 25 into 75 is how much?
3,
3 times. 25 now 100?
4.
4. So the answer is just what? 4 over 3.
Ah, 3, sorry.
All right. All right. So when you're canceling, what to look for? The highest common
Highest
factor.
common
Common
factor.
factor.
And let me tell you something, guys. You see a timetable? Trust me. The timetable. It is very important to know the timetable like the back of your hand. Because a timetable is also a division table, it's also a factor table. Alright? You can divide using a timetable. Do you know that? Yeah, man.
Yes.
You can, right. So the timetable is very powerful. So what you need to do, or what you need to revise, is the timetable and know the words that we're using. Alright, let's get back on track. Alright. Let me see what time is it. So it's 8:45. So technically speaking, we have about 45 minutes remaining. Start 6:30. So end at 9:30. All right. Okay. So when you work out the bottom piece here, so what do we get in its simplest form? 3 over 2. And we have 3 3/4, which is 15 over 4. So this bar here means divide. So we're going to divide it by what? 3
over 2.
2. All right. And then
15.
division, right? And we flip. Let's call it flip.
Flip.
Yeah, man, flip.
2 over 3.
Yeah, man. Then the word is a nice uptown word, not true? It's a rich people word, not true? All right. So then no, we cancel. All right. No, here what I want to know. Do we cancel like this? Can I say 3 into 4?
No.
No, you have to cross multiply.
Right. So we
3 into 3, 1.
right. So we when we cancel diagonally, or we cancel vertically like 4 into 15, but nothing can work. So we can cancel diagonally here. Yes, Sunita. Go ahead.
Sir, I'm not seeing the screen.
Let's see the screen. Let me tell you, there's two. Were you seen it before?
Yes, sir.
All right, it's probably the internet. Internet is running slow. So if the internet is running slow, it might take some time to
So would that be 5 over 2?
All right.
That's 3 in a.
Right. So 3 into 3 goes 1. 3 into 15 goes what? 5.
5.
And
2 into
4
2.
cancel. That's right.
And then 2 another.
2.
Right.
2.
So the answer is just what? 5.
5 over 3.
No man, 5
over 1.
5 over 3. 5 over 2.
Remember, so 2 into 2 goes 1 and 2 into 4 goes 2?
Yes.
So the 2 times the 1 goes down here.
So you break down that, you put that in a improper fraction now?
Well, no man, it's already in an improper fraction.
Mixed fraction.
Mix.
You mean mix? You can if you want to. That's 2.5, right?
2.5, yeah.
Right.
Okay.
But
So, sir,
yes,
me
yes.
get 2 over 5. Still right?
No.
No, sir. You know what you know what you did wrong, right?
Yeah, no, we get it right.
Right. The answers and flip round for the top. For
Yeah, the flip round the 15 and the 4.
Yeah.
2 over 4.
All right. So everybody on the same page? Are we clear?
Yes, sir.
All right. So basically, that's it for fractions. I hope everybody submit this. All right. All right. Let's look at another question. All right. And these questions basically is about using your calculator. All right. Right. Using your what? Your calculator. Okay. Does everybody have a calculator with them?
Yes, sir.
All right. All right. Now, except for part 1, you notice that there's a significant figures. I'm going to go into that. All right. I'm also, it says something about standard form. All right. But before we go into this part, I just want to see if you guys were able to get this correct. All right. So, who wants to go ahead?
Go ahead with what? Which one, sir?
Question number 5, part 1. Who wants to go ahead and tell me what the answer is?
All right, so that's the one that says 2. Sir, I got 6.1.
Okay.
Is that the right question?
The 2 significant figure.
Sir. Sir, is the answer 6?
All right. Tell me what you get when you're breaking up, miss. You're breaking up, miss. Say it again for me, please. Say it again for me, please.
6.1.
6.1. Okay. I want you guys to tell me what you got before you run it off, the 2 significant figures.
6.08.
6.08. All right. So, what you do? Okay, somebody saying something?
It is 2 significant figures.
All right. So, what to do? Let me tell you. When you do these questions, don't punch in everything one time in a calculator. If you do that, you might get it wrong. What you do is that you work out this piece first. You write it down, then you work out this piece first, then you subtract it. But don't try to work out everything one time. Let me tell you, some calculators have been built-in systems to work out these questions, and some calculators don't. All right. Another thing you could do is utilize your brackets. Right. So what you do is a 2.5 times 2.5, subtract. Then you have open bracket. You press open bracket on your calculator. Then you press 2.89. Then you press divide. Then you press 17. Then you press what? Close bracket. Then you press equal. All right. Some of you might try this question one shot and not get 6.08. All right. So I just want you guys to be careful of that. All right. Now the question says the 2 significant figures. I want somebody to explain to me how you get your answer to the 6.1 when you run off the 2 significant figures.
So all right, so all for the significant figure, all numbers that are not 0 are not significant. However, if there is a 0 included, it is significant. So what I did, I count from the 6. So
right.
1, 2, go over to the 8. Because there is an 8 there and it is greater than 5, we add a 1 to the 0. So it becomes 6.1.
Excellent. But one thing, you missed out one important word. They said that something about the 0. Well, what happens is that if it is a leading 0.
Yes.
Right. So that works. So For example, if you get 0.0123, so if the number has a leading zero, 0 is a significant figure. But in this question here, the 0 is not the leading 0, the 0 in the middle.
Right.
So you don't consider that as a significant figure. All right, so very good.
I would call that you would multiply 1.7 3 times equal to 4.91.
Hold on, why 3 times? It's
because the 3 outside the bracket, it would signify that you should multiply.
No, it's not a 3, it's a 2.
It's a 2, you know.
You sure? Oh my God. All right, let me start over 2 times. So I got that wrong, but let me do it just
You still can work it out, man. You still can work it out.
Okay, so it's 1.7 times 1.7 would give you 2.89.
Right, 2.89.
Right. So after you get that 2.89, you'd set it down and you put your plus sign there, and then you go on to multiplying the 1.3 and plus 1.3, that would give you 1.6. And then
hold on.
1.69.
No, it's 1.3 times 1.3.
Yes, 1.3 times 1.3, that would be 1.69. Correct now?
Yeah, man, you're good.
Okay, and then you'll add 2.8 plus 1.69, that will equal to 4.58.
Very good.
And then that would be the answer, or should I continue?
You mean part 2? Well, I'm just kind of curious. How you're gonna continue with that? Unless you're gonna convert that to a fraction, which you know.
Right. So that part of it finished.
All right. Okay. Thank you very much. Who wants to try the other one?
All right, I'll take that one.
Who is this?
Junior once again.
Okay. Yes, Mr. Junior. Hold on.
Right,
Hold on, boss. All right. Go ahead.
Right, so for that one, you'd actually have the top part, which is 4.8 plus 6.9, and that gives you 11.7. Now you're going to, down below, you're going to have, if you want to write, you can write the divide. So it's 1.3 times 0.2, which is 0.26.
Good.
Right, and then you'll actually divide that, the 11.7 divided by 0.26, and you get 45.
Very good.
But
You get 45,
right? Make them bright though.
Sir, if you don't use the calculator, how would you work out that part?
No, we're not gonna kill ourselves with that right now.
Okay.
Because if you notice, the instruction says what?
Use a calculator.
Use a calculator, that's true, right? And also, what you need to understand is that it says determine the exact value. Now, you notice in the question we did a while ago, number 5, it says to round off, not true, to 2 significant figures. All right? But this question didn't want us to what? To round it off. They want us to what? The exact value. So you have to look out for those keywords. I always tell students lots of English language in math. All right, and notice that they put the word use a calculator in bold or full cap. No, that's not full caps. All right, so we have about 2 more. Who wants to take a shot at that? I hear somebody mumbling at the man in bright.
Sir.
Yeah.
So this is computation, right?
Yeah, this is computation.
Okay.
Alright, so
I get that.
What is the answer for number 6? The total answer for number 6, sir.
Number 6. Which one that's?
4.58.
You just completed. Okay, 4.58.
Yes.
All right, thank you.
All right.
Okay, who wants to go ahead for this one?
Me, sir.
All right.
So, where you have.
By the way, who's me?
Kristen.
Okay.
So 3.9 times 0.27. That is going to equal to 1.053. And the reason why I have 3 numbers behind a decimal point is because when you look at 3.9 and 0.27, there's 3 digits behind a decimal point. And then with the next one, it will be 0.82.
Correct.
And when you add those together, you get 1.873.
That's what I don't understand. The square root of the decimal. I would like to know that. Because I don't see that option on my calculator.
What type of calculator do you have?
It's a calculator on my phone or my laptop.
That's the reason why. It have to be a scientific calculator.
I'm sure there's a way to work it out manually, right?
Hold on.
Mr. Steven?
No, man. Well, I mean, it's going to be very difficult to manually work this out of your head. But what square root means, it doesn't mean, say, for example, out of your head. Can you mute your mic, please? I'm here. Just mute your mic, people. All right. So manually, root 100 is 10. Why 10? Because 10 times 10 give back 100. Root, say 9 is 3 because 3 times 3 give you back 9. To manually do this is going to be difficult when you have decimals. So we use a calculator. That's why it says use a calculator. All right. So Roger, you're using your calculator on your computer?
Yes, but there's no square root option.
All right. Are you seeing? Are you guys able to see the screen? My screen? You see the calculator? Is it that you did?
No, we're not seeing the calculator.
Oh.
But in a sense where he's searching for the square root part of it, there should be one with the exact same sign that you're seeing here with the number 2 and X.
All right, Roger. You see on the computer calculator, look to the top left is a view. Look at view. Click on view.
Okay, I'm not seeing any view on my calculator here.
You mind screenshotting it, sending it in the group? Let's take a look at what you're seeing.
Sure, let's try that.
Sir?
All right, let me take a picture.
Sir?
That's more easier.
This is Janet. This is my first time. I've been following so far. Tell you the truth, I have the sharp calculator right in front of me. I see the square root sign, but don't know how to do it.
Okay, press the square root sign.
Here it is.
When you press the square root sign, do you see square root sign come up?
No.
Oh, guess what? Type in a number, then press the square root sign.
Oh no.
The 0.6.
You have to type in number first and then press the square root.
Yeah. The more modern calculators, when you press the signs, they come up.
Yes, sir, because you have two type of the sharp calculator.
Yeah.
What
Then
did she say for the answer when she the square root of the 0.6724?
0.82.
Okay, I see it now. Thanks very much. And
Okay,
what's
right.
the final answer now? You add the 1.053 plus the 0.82.
Yeah.
Okay, thank you so much.
Okay, Reggie,
You're
I'm seeing your screen, but there are no options on this thing here, man. You must have some options for the calculator. Hello?
All right. Okay, Mr. Steven.
Yeah, man.
All right. I understand it.
Yeah, and first of all, it shouldn't be in rad. If you can change that to degree, DEG, that will be okay.
Oh, okay.
All right. Let me just say something to everybody. I think you guys should invest in a scientific calculator for your own. All right, because you're gonna need one for exams. All right,
Yes.
and when you have a laptop calculator or a phone calculator, that wouldn't work. It might work now, but best thing to get a calculator for yourself. All right. All right. Okay, so I lost track.
Excuse me, sir, before you continue.
Yes, June.
I know, like, would you be like teaching us how to use the calculators, to work out certain equations?
Well, let me tell you, when it comes to trigonometry, that's where it takes some skill. Otherwise, in maths, it's just basic. What I'm showing you right now is just basic. But the more technical aspect of using your scientific calculator comes into play when we're doing trigonometry. All right, and it's not so technical. The problem what I have is that you have so many different brands and type of calculators, and all of them kind of different to work. For example, Miss just a while ago, she was asking me how to work with the square root. So what she had to do is to press the number, then press the squared sign. And I can almost tell you that another student with another sharp calculator, it's the other way around. You press the sign first, then you put in the number. All right?
That's how mine works. Sorry to interrupt, but that's how mine works. I have to press the sign first,
right,
then put in the number.
Right. Which is yeah, and to me that's more appropriate because it's more user friendly. It's kind of more user friendly. The older version of calculators is one where there are no signs, you know. But you have to just work with what you have. All right, so I didn't even get to finish this question here. Was kind of caught up. So we said that did we work to work this out? Oh, it was it 45?
Yeah.
Okay, yeah. All right. Okay, let's go to the last one.
Can I work that, sir?
Go ahead, man.
To see if I get it. All right, so they're going to work the square root first. So I got 0.23, and then I'm going to add that 0.23, 0.216 equal 0.446.
Correct. Do you know to work on this part?
Huh?
Do you know to work on this part? Standard form?
No.
All right, guys. So, quick question, guys. Are you guys taking notes? Are you guys? I don't know. What are you taking notes? Do you have your notebook out? It's
yes, sir. Yes.
Right. Okay. So I'm just encouraging you guys to, take out your notebook, and make notes and make jottings. All right. what I find, you know, when you take, okay, Sunita, you want to say something?
Yes, sir. The one that you have the 45, sir. Me not understand that one.
Yeah, me not understand that either. How you reach at that?
All right. So I believe when we worked out 3.9 and the 0.27, we get 1.053. Do you have that? I don't think it's 45. You know, I think 45 is a question up here, so.
Exactly.
Yeah,
that one.
Yeah, we never work it out. We never work it out. Sorry about that. Alright, so the square root of 0.6724 is 0.82. Right, and when you add that, what you get?
0.873.
No man, you're gonna add
It's
1.873.
1.873.
Yeah, well, no sound like school, some primary school picnic.
So we get 1 point.
Whereas this is 1.053, you know, and it's 0.82, so you're gonna get 1.87. All right, so let me explain something about standard form, right? Okay. All right, so there's something called standard form. Another word for standard form is scientific notation. All right? So it's two words, standard form, scientific notation. If you're doing like chemistry, the sciences, they normally say scientific notation. All right, so what is this and what is this all about? So many years ago, when scientists were doing calculations, right? So this is our last 10 minutes. Many years ago when scientists were doing calculations, for example, they calculated very long distances between, so for example, the Earth and Mars, and you know, they find out that, boy, when they're doing the calculation and adding and subtracting, it takes forever. And back in those days, they never have scientific calculator. All right? So you find that calculations for very, very large numbers were cumbersome. And the chemists and the physicists that they work on small weights and small masses. For example, you know, the weight of a proton, weight of an atom, those small numbers, they found out that when you're doing the calculations for those small numbers, you know, they're very hard, very difficult to work with. All right? So you might find like a number is 0.00000068 plus 0.0000138078. And when they're supposed to add those numbers, boy, it just takes a lot of space. So what these scientists did is to come up with a notation to represent very large numbers and to represent very small numbers. All right? So I'm expecting you guys to be writing. So, and that notation is called scientific notation or standard form. All right? And this is the form. So basically, we have a number that's between 1 and 10 times 10 to a certain power. So this is standard form. So let me get an example. 3.7 times 10 to the negative 8. So this would be like representation of a very small number. So 3.7, write 3 properly. So this is our standard form. So this is how your answer should look like. All right? Okay. All right, so this is the form. Everybody understand the form?
Yeah.
All right, so what I'm going to show you now is how to convert regular numbers to standard form. All right, so example number 1. What I plan to do next class, you see, is I'm going to try to see if I can set up a board and try pretend as if I'm in a classroom and see how that works out. All right, so convert, got this number here, 1763. All right, I want to convert that number 1763 to standard form. All right, so my question is, where is the decimal point in this number here?
Where the one is?
In between the two ones.
3.
It's at the 3.
Oh.
Remember, it's a whole number, right?
Right.
So you couldn't put it between the 1 and 7. It's like, you know, it's like you make up a number. It's like you're gonna change the number then, basically. But if you put it at the 3, you wouldn't change the number. All right? Okay, so this is what we're gonna do. I need to put this number between 1 and 10. So my question is, where would you, can you mute your mic please back there? There's some dogs barking. All right, so my question to you, where would you put this decimal point to make the number between 1 and 10? Because in standard form, the first number has to be between 1 and 10.
You would move 3 decimal places.
Now tell me 2 numbers where you're gonna put it.
Okay,
Between
so
the
in
1 and-
between 6 and 3.
But if you put it between 6 and 3, you'll get. You'll
Sir,
get 1.
between 1 and 7?
Right, right, that's correct. If you put it between 6 and 3, you'll get 176.3. That's all.
Yes.
What standard form say? The number has to be between what? 1 and 10.
Oh, the number.
Right. So if I put it between 7 and 6, I get 17.6, which is greater than 10. Suppose I put it right here, so in front of the 1. Would that be correct?
No, sir, because it's less than 1.
Thank you very much. It's going to be less than 1. All right, so the ideal place, or the correct place to put it, is actually between what? The 1 and
1
the 7.
and 7.
Because you'll get 1.763. So 1.763. So we have one part of the answer. Multiply now by 10. So it's always 10. Now you're going to have a power up here. So now, how many places to the left did we go? Let's count.
Sir.
Yes?
Sorry. Sorry if you stop you, sir. But because me know want you go on no further, I don't really understand the 1 and the 10. Right? Because what me really understand is that what I'm thinking of the place value when you talk about 1 and 10. So I know that 3 is the 1 and 6 is in the value of 10. 7 in the value of 100. So that's how I'm looking at it right now. So I'm kind of lost when you say to in between 1 and 7.
Mm-hmm.
You know? That's where I don't understand.
All right. Are you following this statement here? What does this statement say?
No.
Okay, that's the problem. Standard form. Please mute your mic. Okay. Standard form requires us that the first number have to be between what? 1 and 10. All right. So if you put look, all right, if I have all right, suppose I have this, right? How much money that?
$1,000.
It's 1,000, true?
1,000.
All right.
Yes.
How much money that now?
It's 100.
It's 100, not true? Right? And then what?
10.
That's 10, not true? And then that's what? That's 1.
1.
That's 0.1. All right? You following that?
Following that.
All right. So you what now? This is a number that was given. Let me write it over again. 1 point. No, there's no point in it. 1,176,3. Not true? All right. Think about it as money. That's 1,763. Right? So the point right is not true. All right. Now, if I put the point right here, so how much money that?
$176.
Right. If I put it right there, so how much is that?
17.
17. Not true. If I put it right there, so how much is that?
$1.
$1.76 and some change. Not true. All right. So
True.
let me ask a question now. Which of these values have 1.763? I have 17.63. I have 176.3. Which of those three numbers lie between 1 and 10?
$1.7.
1.7.
Okay.